This is Matthew Sivaprakasam presenting our work on ensembles for online dynamic modeling in off-road terrain. For effective planning and controls in autonomous driving, accurate vehicle modeling is needed in order to understand how the vehicle will respond to given commands given a certain state. In simpler environments like cities and paved roads, structure and consistencies allow us to use simple models that are still relatively accurate. However, these consistencies can't be taken for granted in off-road environments, where the terrain is super inconsistent and variable. In these situations, we can't use the same simple vehicle model without losing accuracy. Our approach has two stages. In the first stage, we generate offline experts by collecting step responses and modeling transfer functions off of them. We then set up these experts in an online ensemble that predicts the best expert at a given step in simulation. The accuracy of each expert at the step is then used to influence the next prediction. This experiment was done in our physically accurate simulation in randomized terrains, where the green areas correspond to more friction and the red areas correspond to less. For the systematic data collection, we iterate through a range of slope and friction values and collect step responses for commanded velocity and steering angle. We then use this data to fit transfer functions by using ARX time series models, one for each set of friction and slope. These ARX models maintain a buffer of the past two states and predict the next state given the current and commanded state. The transfer functions predict the velocity and the steering angle of the car. So to predict the actual state of the car, we feed these transfer functions into a bicycle model, which then outputs the predictions of each expert. The figure on the right shows the distribution that occurs when you forward sample the predictions from various experts. It was found that the optimal expert is never consistent, and it changes as the vehicle moves across the terrain. So we set up an online learner using the ensemble. A vector of weights is maintained, and the learner chooses which expert to use by using these weights, where each weight corresponds to the probability that it will be chosen. Before the next step, the weights are updated based on the individual performance of each expert. We implemented various policies for this process, including randomized weighted majority, generalized weighted majority, EXP3, and we also use a separate approach where instead of choosing a single expert, you make a prediction by doing a weighted average of all experts. The left figures show the predictions of all experts in 2D space, which shows a somewhat wide distribution. The right shows the ground truth in green, our method's predictions in blue, and the predictions using just a single expert in red. And as you can see, our predictions are generally closer to the ground truth than the baseline in red. Another indication that our method offers some improvement is by monitoring the regret of the learner, where regret is defined by the difference between the learner's cumulative loss and the minimum possible cumulative loss. The spikes we observe in the regret are explained by sudden changes in the properties of the environment, so the learner needs a chance to adjust accordingly. In conclusion, we introduce an application of online learning for off-road driving to improve dynamics prediction. Our ensemble method results in a higher accuracy for predictions by leveraging past performance in decision making. One current limitation, however, is that it relies on prior systematic data collection. For our future work, we first plan to test its performance in real life by setting it up on our physical platform shown on the right. There are also some downstream applications for this, for example, algorithms that require accurate vehicle models like MPC and RRT. There are also some extensions we want to try. For example, learning a multimodal latent space and then using that to cluster online data into new experts that are then fed into the ensemble. We also are thinking about exploring generating an ensemble of residuals.